In this video, we're going to talk about property of sampling distribution of mean. So the sampling distribution model of mean, when a random sample is drawn from a population with the mean mu and standard deviation sigma, this is the population mean and the population standard deviation. We have to follow in the mean and standard deviation for the sampling distribution. So that means the sampling distribution is going to follow this one. The sampling distribution mean is equal to the population mean, and the sampling distribution sigma, which is the standard deviation, is equal to sigma divided by the size of the sample. So as you can see, if this is sampling distribution, they have a small notation, which is x bar, to show you that, hey, this is going to represent the sampling distribution, not the population. Population mean or population sigma is just like a symbol Greek notation, Greek letter, mu or sigma. Okay, starting the population is a normal distributed. A person measures glucose level 1 hour after ingesting a sugary drink varies according to the normal distribution. Mu is equal to 125, sigma is equal to 10. All right, so now take a look. This one is the population mean and population sigma. If a single glucose measurement is made, define and draw the distribution. What is the probability that the single measurement is greater than 140 milligrams? So let x be the single measurement of a random person glucose level. Then x is going to follow a normal distribution with mu 125, sigma is 10. So that means in a GeoGebra, if you put this, you will see a graph look like this one. The center, the medium is going to be 125. The first standard deviation is 135. On the left, the first standard deviation is going to be 115. And here is 145, 105. And then we want to find out the probability that that single measurement is going to be greater than or equal to 140. Now, we can use GeoGebra help us to find the solution. Here in GeoGebra, our mu is equal to 125 and sigma is 10, and we want x to be greater than 140. So the probability of that greater than 140, oh, not 150, 140, is equal to 0.0668. All right, so we can write this down. This is equal to 6.68%. You can write into decimal form or percentage form, either way. So if the measurements are made on 3 different occasions and the mean result is computed, discuss each condition requires to use sample distribution for average of these 3 results. So sample size is equal to 3. First of all, we will assume that this is going to be independent because you measure one people is not going to affect the other people's glucose condition. The second one is the randomization should be checked. The third one is sample size. So these 3 are the central limit theorem that we talked about last video: independent assumption, randomization, and sample size. If you meet this condition, then you can apply distribution of mean, sampling distribution of mean. Okay, but our sample size only 3. These might be too small. However, earlier we also talked about that, hey, oops. If the population is normal, no sample size conditions is required, which we are very lucky because they tell you that, hey, the glucose level follow the normal distribution. So that means we check all of these 3 conditions. If the parent population is normal distribution, we don't need to worry about sample size. Okay, so define a sample distribution model and its parameter. Draw and label the model relative to the model. So what is parameter? Parameter means we need to know the sample distribution's mean and sample distribution's sigma. So we know that they are going to follow the normal distribution because we don't need to worry about sample size as long as the population is normal. Then, even though you just have 3 sample size, the sampling distribution is also normal. So we let X bar, remember that the sampling distributions use X bar to represent it. Let S bar be the random variable of mean of 3 different measurement, 3 random measurement. Okay, so our sampling distribution mean x mu sub x bar should equal to the population mean because that's the formula they give you. The population mean in this case is 125 milligram per dl. I don't know what does dl mean. And then the sampling distribution sigma, I put a small s bar in the bottom, means this is represent the sampling distribution of means. It's equal to the population sigma divided by the square root of the sample size, which is the population sigma is equal to 10, is given. And the sample size, we are drawing 3 random samples, should be square root of 3. And then you use a calculator, you will get the sigma is equal to 5.7735. So that means our x bar is going to follow the normal distribution with mu 125, sigma is 5.7735. Okay, so this one basically is our 3rd graph. Let's go back and take a look. Our 3rd graph, these populations distribution, it's the distribution of mean, which is normal. Like I say, they will have the same mean with a smaller standard deviation because they're less spread out. All right. Next one, what is the probability that the mean of these 3 measurements is greater than or equal to 140 milligram per dl? So we want the probability of sample mean, which is x bar, because we are looking at the mean of these 3 measurements, not the population. So that's why we use x bar to represent the sampling distribution. The random variable comes from the sampling distribution greater than 140. Now we can use GeoGebra. Our mean will remain the same, but sigma become 10 divided by square root of 3. And then we want to know if x is greater than 140. In this case, is 0.0047. So we got 0.0047. So why this is so much smaller than that one? This one is approximately 0.47%. So for the population, we have what? They have the same greater than, the measurement is greater than 140. You got 6.68%. But when it comes to sampling distribution, if you want it greater than 140, it seems like very less likely, which is 0.47%. Why is that? That is because the sigma from the sampling distribution, which is sigma sub x bar, is way smaller than the population sigma. So the bell curve is less spread. So that means it's less likely to be greater than 140. Okay, so what is the 95th percentile for the average of these three results from the person? So now let's look at GeoGebra. We want it to be 95th percentile. So that means we want most of the data is less than. So it should be 113.5. So that means if you're greater than 134, the measurement unit, that means it's going to be a 95th percentile. Okay, so that's it for the sampling distribution of mean. We will do more exercise in next video.